Oh yeah, it'll come on.
Oh, okay.
Okay, so we're going to look at the traits of ionic versus covalent because we're going to use them in lab on Monday. We're going to start with covalent. I'm going to ask you a couple questions, and I'm just going to make a list of traits. If I have a covalent bond, what's going on with the electrons? Okay, so in a covalent bond, I'm going to say electrons are shared. And we would call these non-crystalline because they don't form, most of them don't form crystals. They're just blobs or powder-like when they're solid. How many people in here have ever tried to put sugar in cold iced tea? Have you ever tried that?
Yeah.
Like when you're out to dinner and they bring you unsweet, and my husband does this, and then they want sugar in it. You dump the sugar in, you dump one packet in and you stir. Then he'll dump the second one in and stir some more. Pretty soon I look at his cup and he's got like sugar all on the bottom of the cup. It does not dissolve. Sugar is a covalent compound. So we can say that they do not dissolve well in water. How can I make sweet tea? What do I have to do? I have to heat up the water. I have to add energy to make it dissolve. Add energy to break the bonds. What they will do is they will dissolve most of them in alcohol, like isopropyl alcohol. If I try to make a solution. So things that we use in here, like we'll use later on, phenolphthalein, which we've used already this year, that's a covalent compound. When I make that, I have a powder. I put water in it, but I also have to put isopropyl alcohol in it because that's what makes the phenolphthalein dissolve. So you have to understand the compounds you're working with in order to know how to use them. These are non-conductors because there's no charge present. We're going to use something in lab on Monday, which I'll show you how to use it, but it's called a conductivity meter.
AJ Airy, if you're in a building, come see me, AJ Airy.
He's not in the building. So they're little devices, and they have two prongs. When you put those prongs in the solution, if the light bulbs light up, you're conducting electricity, and if they don't, then it's a non-conductor. Your covalent compounds you should see will be non-conductors. That's a way you can figure out what you've got. I would also call covalent compounds, or think about this, they have very low melting points and low boiling points. So if you have a group of chemicals and you want to know what's ionic, what's covalent, you can test how long it takes for them to melt. Another way. So there's lots of ways we can test to figure out what kind of chemical we have. Okay, so that's good for covalent. Let's look at ionic characteristics. I'm kind of going to work through them the same way. I'll flip this over so I can see what I wrote. What would you tell me about the electrons in an ionic compound? What happens to them? What? I still didn't hear you. They don't get shared. They get what? Given away or taken, right? So I'm going to say complete, I think this is how we said it before, transfer of electrons. Ionic compounds are also something called crystalline solids. They're crystal. There's different shapes of crystals. They have something called a crystal lattice. And when bonds are broken, we say lattice energy is given off. So a crystalline solid is what we call a lattice. Now I want you to think, you've probably seen this before, driving around. On some old homes, or like in a garden, you'll see a lattice that a rose might climb up, or they sometimes put it along the bottom of a house. It's all that crisscrossy stuff. Yeah, that's kind of what it's like. They form individual crystals that grow on top of each other to actually make the compound or the mineral. So when you look at them, they look like different shapes of crystals, and that's one of the things we're going to do in lab. You'll be able to see the difference, hopefully the difference between them. If you think about a good example here, one that you should be able to relate to or should have looked at before, is NaCl, which is table salt. It's really not really, it's halide. Have you looked at salt before? Like really checked it out? It's like little cubes stacked on top of each other. That's its crystalline form. If I want to break salt apart, I have to break apart that lattice. That's why it's called lattice energy that's given off. Because whenever you break bonds, energy is given off. Does salt dissolve in water? Have you ever tried? Okay. These do dissolve in water. But not in alcohol. In solid form, they're non-conductors. In solution, what happens to an ionic compound when I put it in solution? If it dissolves in water, what's happening really? I start with this plus this, and I put it in there. What happens to my Na and Cl if it dissolves? They break up. They come apart. So in that water, I would now have Na plus Cl minus floating around. They both have a charge, do they not? Yeah, that charge causes the flow of electrons, creates electricity. So, in solution, they conduct electricity. Have you heard of a lithium-ion battery? That's exactly how it works. The flow of electrons, that's how batteries work. It's electrochemistry. The flow of chemicals, the flow of electrons. That's why they can conduct. These guys have high melting and boiling points. So you're going to have to use all that information in lab on Monday. Anything in there you have questions about? I think we should probably write a little blip about the ionic compounds. An ionic compound, when in solution, breaks into its parts. With charges, or maybe I should say it's ions with charges. I'm gonna put ions there. So it conducts. That makes sense? Are we good? Yeah? Alright, so now we're going to make some polyatomic ionic compounds. Yesterday we made binary ionic compounds. These were made of a single atom ion plus a single atom ion. And when I say that, I mean it was one atom off of the periodic table that had become an ion. We didn't have anything that was like Cn or ClO3. They were all just two pieces from the periodic table. These binary always means two parts in chemistry. We can have binary molecular compounds, like all of our diatomic molecules, and we can have binary ionic compounds. That means it's just made of like something like Ki, potassium iodide, would be a binary ionic compound. So today we're going to work with not binaries. What? No, they're more than that. We just call them, that's why they're called polyatomic. Poly means many different. Polyatomic ionic compounds. For these, one part, either anion or cation, is composed or made up of two or more different types of atoms. Everything on the board behind me, there's nothing up there that's not made of at least two different types of atoms. There's one that's made of three. Bicarbonate, HCO3, 1 minus. The rest of them are only made of two. So, let's look at this. Let's look at type 1. It would be one atom plus one polyatomic ion. And we're just going to do some examples. I'm going to start with what is called ammonium chloride. Now when you look at this, when you see the wording, you should recognize ammonium. Oh, that's not an element I've memorized. That's not on the periodic table. When that little switch goes off in your brain, not on the periodic table, then your brain should go, oh, that's one of my ion cards. That's one I'm supposed to have memorized. I'm only making you memorize 20. There's over 100 of these. So if it's not one you have memorized, you'll be getting it as a gift on the quiz or the test. You just have to know how to use it. But ammonium is one you're supposed to memorize. It's actually on Monday's quiz. It's also behind me on the board. So, what's the formula for ammonium? NH4 plus. 1 plus. Chloride, do you recognize that from the periodic table? Yeah. You should, yeah. What group's it in?
7.
Group 7. A, or 17. What's the charge on chlorine? Yeah, 1 minus. Then I treat it, once I figured that stuff out, I treat it the same way I did before. It's a +1 plus a -1, which gives me 0, correct? Right. This cancels out this. So when I write it, I just write NH4Cl. And I would call it ammonium chloride. So we do our canceling out the same way we did with the other stuff. We just have more atoms involved now. Let's look at this one. I'm going to give you ammonium again. Ammonium, it's a little bit different. Sulfide. See if you can figure that out. Ammonium sulfide. Can you do it? We know what ammonium is. Sulfur is in what group? 16. Everybody in group 16 has what charge? 2 minus. Anybody brave enough to tell me how they put those together? What's your formula? Well, let me ask you this. How many ammoniums do I need, Evan? 2. Okay, do you guys all agree with that? I have to multiply by 2, which means I need 2 of those. Then the question becomes, how the heck do I write that? I don't go N2H8. What did you do?
I did 2 and H4.
Okay, so that would be okay if I was balancing an equation, but it's not the way that I write a formula. And that's okay, because you don't know.
Is that like the parentheses?
It is. It's one where I do this. NH, anytime you have polyatomic and you have more than one, you put it in parentheses and you put the number behind, the subscript behind it. That tells me I have everything in here times 2. And then I would write my S, because then they cancel each other out. Then I could ask you this question. How many atoms in this compound? See if you can figure that out. That one? What are you going to say, Evan?
11.
I'm going to agree with you. 11. Explain how you got that.
I just said n times 2.
Okay. So we had 2 plus what?
8.
Yep, 2 times 4 is 8.
And then plus S, so
Plus 1 is 11. Y'all know how to do that? Are we good? I'll ask you another one. We'll see if you can get it. Okay. Now, let's try, I'm going to give you something totally different. Let's try hydronium phosphate. So you're going to have to get your other cards out because this is not a 1 minus. Phosphate is different. So you'll have to go to your bag and get your other 9 cards out and find phosphate. That'll give you your charge.
is hydronium?
No, hydronium's up on the board. It's one of the ones you're supposed to know. H3O plus. Make sure you can find phosphate. Check your card. It should be PO4 3 minus. So when I look at this, I should be able to tell my lowest common multiple is 3, and then I say to myself, okay, 1 times what equals 3? 3. So I'm going to multiply this by 3, or I can do the old switcheroo. And then I'm going to write H3O 3 times, and then I only need 1 phosphate, right? So I'll write, whoops, P SO4. Now, figure out how many how many atoms are in that compound and then stand up. Now find your partner and check. See if you guys agree on the number. So let's look at this. My H is 3 times 3. We got 3 of these. I got a 3 outside, so I've got 9 hydrogen. Plus 1 times 3 for oxygen. I've got 3 oxygen. Plus, how many phosphorus do I have? 1. Good. 1 phosphorus. Plus, how many oxygen? 4 oxygen. So I've got 9 plus 3, which is 12. 13 plus 4 is 17 atoms. I heard that from most of you as I was listening. So we should be good on that. Let's try a harder one. No, this isn't really harder. Let's just see how you put it together. Let me tell you this. Single atom ions don't use parentheses. So if I only have one atom that's making my ion like Cl, I would not go Cl3. That's wrong. I would just write Cl3 because there's not more than one type of atom there. So keep that in mind, and then I want you to try this next one. Sodium sulfate. Sulfate, you're going to have to go to your other 9 cards for. It's not in the ones you have to memorize for Monday. See if you can figure the whole thing out, and when you're done and you think you have it, stand up, and we'll see if we all agree. Sulfate's in your other 9 cards. It's not on the board. Yeah. There's a picture of it on Google Classroom. I just put one on today. Yeah, in case you didn't hear that, you guys, I put a picture of that on Google Classroom today just in case you needed it over the weekend. I haven't posted it yet, but as soon as I download this video and post it there, then I'll open that up for you guys. Getting a little chilly in here. I think they turned the air conditioning on. We need to talk about it? Yeah? Okay. So I'm going to go to my periodic table and I'm going to find sodium. It is Na+. I know that. Then I would go to my cards or my brain and find sulfate, which I know is SO4 2-. Then I'm going to look at my charges and say, what's my least common multiple? 1 times 2 is 2, so I have to make this a 2. I do that by multiplying by 2. Does that make sense so far? Okay. So then I would write that as Na2SO4. Notice I have 2 of them. I didn't have to use parentheses because there's only one type of atom. Raise your hand if you got that. Good job. You want one more to try? Yes.
Question.
Sure.
So, doesn't that simplify or something?
No, you don't have to because you're charged, this is a whole unit. So this 4 only goes to the oxygen. If I make this SO2, I now have sulfur dioxide, which is not what I asked for. Okay, so you never have to, if it were in parentheses and that 4 was outside of here, then you would have to simplify. So you don't simplify a polyatomic unless it's in parentheses, and then you might need to simplify it. That was a good question. All right, I'm going to just give you one more, and then I'm going to have you try something else. I'll try something that's on the board. Let's try calcium chlorate. I'm going to have you try 2 more. Calcium chlorate and hydronium. Oh shoot, I got to look at your list. I don't remember what else you have for. I also don't know where I put it. Maybe I put one in here. Well, we'll do this. I know you have that card. I need to get myself a list. There. Try those 2. When you're all done and your lab partner's done, move together and check them. And then we'll talk about what we need to talk about. The hydronium phosphate. Did we? I was trying to think of another. I didn't have a copy of this. I had to get up and get one. I didn't want to give you one you didn't have.
Is that our homework?
No, that's not your homework. All right, let's talk about it. First of all, do you agree with your partner?
Yeah.
Every group agree? Anybody not agree? Noah, tell me what you guys had for calcium chlorate.
C8-3, ClO3, 2.
Okay, so what's the chart? Do you all have that? No, what do you have? C. Yes. Calcium, did you use calcium as a 2+ or a 3+? Use this as a 3+, and this is a, this is a 2+, and that is a 3+, 3-. How'd you come up with this 3 and 2? Calcium is a 2+, this is ClO, 3, 1-. Yeah. Yeah, you probably put these together in your brain. You got to be careful about that. That's a common mistake. It's a 2. This is a plus and a minus, which tells me the least common multiple is 2. So I have to multiply by 2 here, which gives me not this, but this. Apparently this one we already did. Sorry. That was a. Now I'm going to give you some 2 of them in words, and I want to see if you can figure out what they are. Or I'll give you the formula and you name it. I'll give you the correct formula. CaHCO3 2 times. And then NaNO3. Name both of those. The naming's way easier than making the formula, I think.
said solutions.
Gee.
Is that Isaac?
Okay.
Kinda sound-
Did you get your, you got the mouse calculus, right? Okay.
What's going on?
I got calcium bicarbonate and sodium nitrate.
It's not sick. I wanna say hi to Isaac and Clark.
All right, so,
What was going on? Is Isaac and Clark?
oh, they're making mousetrap cars and they're making electrochemical cell devices, so there's a lot going on. Now, who named this? Did you check with your partner?
No, were we supposed to?
Yeah, let's check with our partners and then we'll talk about it. Did you already check? Yeah.
I got,
Did you agree?
Yeah, we did.
Sodium nitrate.
Yeah.
Sodium-
You have calcium, what do you have?
Bicarbonate and sodium
Sodium nitrate. Isn't it so fun to say?
bicarbonate.
I was almost doing it.
Okay, so here's my question. This is important. What else could I call this?
hydrogen carbonate.
Yes. Don't let that confuse you. This could be calcium, hydrogen carbonate. It's an ion that has two different names. Be sure you know them both because I'll put them both on the quiz somehow. And what is this one?
Well, it's sodium nitrate.
Sodium nitrate. Good. Not nitrite, but nitrate.
It's okay, though.
Sorry, Miss Beal.
Did you say nitrite? I didn't even hear it. Did you say?
100% said
Okay.
that. Right, Carl?
Okay.
Yeah, there you
Good job.
Good job, Kyle.
Are we good with this? All right, so get that packet that I gave you yesterday. I'm going to tell you what you can work on today. It's due Monday. Listen carefully, Kate. It is the back of the third page.
Wait,
And then-
the second page.
It is your second page now, sorry. The back of, if you tore out the second page, this is now your second page, which probably starts with page 5. It has the number 5 on it, maybe?
Is this it?
That's it. Now, let me tell you what you don't need to do on that page. Let me have yours for a minute. I'm going to mark some off. I want the one you're supposed to do tonight. Yeah. Okay, so listen, I'm going to get rid of a couple because you don't have the ions for it. I got to get to the right page. Okay, so you're going to get rid of number 9, number 11, and number 9. No, you can do 19. I think you have oxalate.
No, that don't sound familiar.
It doesn't. Let me look at my. Well,
Is it the one with the page with all the dots and stuff?
C204.